Okay, so today we are going to find the inverse of matrix by transformations. So we have two kind of transformations. One is called row transformation, second is called column transformation. Okay, so before applying any kind of transformations, first of all we find the determinant of a matrix. So determinant of A is equal to, okay, so simplification will be minus 2 minus 1 equal to minus 3. Then we write, since determinant of A is not equal to 0, okay, therefore A inverse exists. Then we write a statement, consider A into A inverse is equal to I. Therefore, so now we substitute the values over here. Okay, so A is our question, 2 1 1 minus 1. Okay, now on the right hand side we have I is unit matrix. The order of unit matrix is decided from the question. If the question has a matrix whose order is 2 by 2, then the order of I, the unit matrix, will be again 2 by 2. Okay, so it is 1 0 0 1. If order of a question is 3 by 3, then order of I will also be written as 3 by 3. Okay, now very important part, try to understand the process. What we are going to do here is that we are going to transform this matrix A in this matrix I. Alright, so let's start. The very important requirement is getting the 1. So first of all we try to get 1 at this place. Now looking at the question, we have 2 and 1. Okay, so we want 1 in the first row, but where actually it is in the second row. So we can apply the operation of R1 interchange R2. So because of this operation, both row 1 and row 2 will be interchanged on both the sides. Okay, so the whole R2 from left as well as right will be shifted to R1, and whole R1 will be shifted to R2. Okay, so we got this one over here as we had desired. Now after getting this one, we will get 0 in the same column like this. So in this question we have 2. So see what we are going to do. We are going to use these elements. So we have 2, we have 1, and we will try to get 0. Okay, this 2 is coming from R2. This one is coming from R1. Okay, now what to do to get the 0? So let's multiply this 1 by 2 and then do the subtraction, right? So 2 minus 2 will become 0. So our operation should be R2 minus 2R1. So operation should be done as R2 gives R2 minus 2R1. One thing is very clear, the desired change which we want, okay, that should be written in R2, right? We want change in R2, hence we will say R2 gives. If we wanted the change in R1, I would say R1 gives operation, whatever it is. Okay, so now we go to the next step. Okay, here R1 will be copied as it is, right? Now what to write in R2? Look at the operations. First of all, R2, the first element of R2 is 2. First element of R1 is 1. So we put both the elements So we should get R2 minus 2 R1. So on simplification, answer is 0. So we will write 0. Okay. Similarly, our next elements are these two. So element of R2 is 1 minus 2 times element of R1 is minus 1. So on simplification, it should be 1 plus 2, that is 3. So our required element is 3. Now we go to the right hand side. Same operation will be applicable to the right hand side also. So we are going to deal with now these two elements. Okay. So first element of R2 is 1, first element of R1 is 0. So 1 minus 2 into 0. So we are going to get 1. So the element is 1. Similarly, if we take these two next elements, okay, so we will write 0 minus 2 into 1 is minus 2. So we have finished the first operation. I hope it is very clear to you. Okay. Now after getting this 1 0 pattern, okay, just as I had explained over here, right, we wanted 1, then we will try to get 0. After getting this 1 0 pattern, we will not use this row, that is we are not going to use R1. The reason is that if we use R1, so possibility you can get the 1 over here, but this 0 will be lost. Then again to get this 0, you have to go for some operation. So like this will keep on going and going. There is no end of this. Okay, so we don't want to go up to some n number of steps. We have to minimize the number of steps. So for that purpose, what we do, we just lock this R1 so that 0 will be maintained. Okay, now our priority is to get 1 in R2. Okay, now we go to the question. We have 3 in the place of 1. So the only option left is divide by that number 3. So as it is in R2, so I will say divide R2 by 3. Therefore, so we copy this parts, R1 copied. Okay. Now divide R2 by 3 means each and every element of R2 will be divided by 3. So 0 by 3, 0, 3 by 3, 1, 1 by 3, and this is minus 2 by 3. Is it okay? Okay. So now we got here 1. Okay, now we go to that structure again. After getting this 1, as we had discussed now, after getting this 1, now we will try to get 0 at this place. But currently we have minus 1. See this one in the place of 0. So how to get this 0? How to convert this minus 1 into 0? Using this 1. So let us see. We have minus 1, we have 1, we want 0. So obviously we should add these numbers. So this is coming from R1, this is coming from R2. So operation is R1 plus R2. We want change in R1. So we will say R1 gives R1 plus R2. Alright? Okay. So in this step, we are going to copy R2 as it is. So 0, 1, 1 by 3 and minus 2 by 3. Okay. Now R1 plus R2. So we are going to add R1 and R2. Addition of these two elements. So minus 1 plus 0 will be, minus 1 plus 0 is 1. Okay. Then we are going to add these two elements. So minus 1 plus 1 is going to be 0. Okay. Then we will be adding next two numbers. 0 and 1 by 3 will be 1 by 3. And finally, we are going to add these two numbers. So if you have doubt, we can do it in the rough work. it will look like this one. So on simplification, it should be this one. Then we take LCM, so that should be 1 by 3. We should be writing here 1 by 3. Okay. So by the way, if you look at the question on this one step, on the left hand side, we have arranged 1001 pattern. So that is the unit matrix I. So I into A inverse is equal to the answer whatever we have on the right hand side. Okay, now what we find here is every term is having the 1 upon 3. So we can take common. 1 upon 3 can be taken from each and every element of a matrix. So what is remaining? So from this 1 upon 3, 1 upon 3 is gone. We are left with 1. On the same line, from this element 1 upon 3 is gone. We are left with 1. Okay, similarly the next. And from this 1 upon 3 is gone. So we are left with minus 2. Okay, so finally I into A inverse is A inverse. So it is 1 upon 3, 1, 1, 1, minus 2. Alright. So this is the way or the method to find the inverse of a matrix whose order is 2 by 2. Okay. Fine. Now let's try a matrix whose order is 3 by 3. It is 2, 0, minus 1, 5,